We're right up here. And then we parked at the Triumpha Pass right down there. So this map is, this is a 1 inch to 2,000 foot scale map. So it covers quite an area. And then the Yerba Buena Road, it goes on down here, down to Little Sycamore Canyon. So if you drive back that way, you'll get out of these, about halfway down, you'll get out all this red colored stuff and you'll enter this gray and purple. And that's the sedimentary rock that is in the Topanga Formation. And then actually at some point you would cross this thing here, it says anticline. So that's a sequent anticline, and that's where the rocks are folded up like this. And so everything north of that dashed line there, everything's tilted back this way, all the way to the Canal Valley. We can only see a little bit of this structure before it goes offshore, but it continues offshore. There's offshore what are called seismic lines, where they shoot energy down through the water and into the ocean floor and down through the strata below, and you can get those images and look at what is going on down there in the subsurface.
Is there any oil?
There is oil out here, offshore probably. Here it's been uplifted too much to, if there were any traps for the oil, they've probably been breached and eroded away. But yeah, the basins do, I mean, these deep basins are what takes the source rock for the oil down to deep enough depth to get heated up so they generate the oil. And that formation I was talking about, I don't know if we have any of it on this map or not. Doesn't look like it. But to the north of us, in the Canal Valley, we'll start picking up this unit over here called the Monterey, and that's the source rock for most of the oil in California. And the California basins are thermally very cold. That means as you go downward, they don't heat up very quickly compared to other basins in the world. So our basins have to get buried very deeply to generate any oil at all. And so the oil pods, where the generation is actually happening, are very small areas here and there. There's a couple over in the San Joaquin Valley. There's one in the Ventura Basin near downtown Ventura, and then one offshore in the Santa Barbara Channel. But they're actually, even though we have these oil fields spread over a large area, the oil is generated from a very small pod, and then it sort of migrates up because oil is lighter than the surrounding formation waters. And buoyancy sends it to the surface, and that's why you have oil seeps too. And most of the oil seeps we have, like at Carpinteria, if you've ever been to the beach there, or if you drive up to Ojai, there's a big oil seep east of there. They're along big faults. So these faults become conduits. If they go far enough down into that oil pod, if they can actually reach down there, they're big enough faults, the oil seeps up along the faults and then makes it to the surface. But right back to the map, so we've been walking pretty much through this thing called TCVAB. And that's the abbreviation, if you look on his map, that's this unit right here, there. And then you look down here and it explains what it is. TVAB, right here, andesitic breccias. Gray, maroon gray to brown breccias of unsorted angular fragments of fine-grained andesitic rocks in andesitic detrital matrix. Well, when he says detrital, that means he's talking about this thing has become sedimentary. Crudely bedded, which means it's got some layering in it. Moderately coherent, which means it doesn't break apart too quickly. And erosion resistant, that's why it's holding up the Bony Range. Probably erupted marine, subaerial of the marine, and deposited as volcanic debris flows, lahars, and fanglomerates. Anyway, it just goes on about that. And then he's got another one called basaltic breccias. That's another, we haven't got into that one yet. That's like that redder, that's this one. The other ones are, so that's the andesite breccia, the redder one is the basalt breccia. So if you drive down Yerba Buena Road, you would go through that unit. Now these things here, these are these plugs, these necks, like here. That's what it looks like when it gets to the surface. Okay. So that's actually where the magma was coming up. in there. Okay, and so that's going to have a little different look to it. Usually when it's on the surface here, when you look at the actual minerals that are in here, they're going to be pretty small. You might see some with the eye, but you need this hand lens, this little magnifying thing I have here, to really see the individual crystals. And that's how the geologists, when they carry that around, so when they're in the field and they break the rock open, they can look at a fresh piece and they can look at the minerals and they can identify roughly what kind of rock it is in the field. But when you go to one of these plugs, because it cooled slower, because it was at depths, it wasn't right at the surface, usually the crystals are much larger. And so if we went there, you'd be able to see them in the eye pretty easy. And then if you went to a place like the Sierras, where you have all that granite, that's cooled down at 10 kilometers or 15 kilometers, and nothing happened to it since, except it got eroded into. Those crystals can get really big. I mean, they can be, there's quartz and feldspar crystals the size of my thumb, that are. So if you go back to Sierras, when you look at that whitish gray rock that makes up Sierras, you'll see all. You can see the quartz, and you can see the feldspar, you can see the biotypes, all the stuff that makes it up.
Yeah, our family makes hooch for family functions. So like hooch, like moonshine. So like,
all right.